this one together. So I had the other classes do it on their own. They both, ironically, had the exact same, or surprisingly, both classes had 12 kids who got it right. It's weird. This is off the last BC practice test I gave, but it was in the B category. So it's something you guys should be able to do as well. So when I go and look at this, I'm kind of taking a look at what I've got going. I'm working with I'm working with definite integrals. I don't know what f of x looks like. I don't know what g of x looks like. I know that this notation means that I'm going to be accumulating signed area between the curve and the x-axis. So I'm digesting that. I also go to what I'm being asked to find, and I know, okay, they're testing me on some properties. They're testing me basically just on properties of definite integrals. So let's go use those. What property did I say we can do when we have a subtraction or addition? I can separate them and deal with f and g separately, which is going to be really helpful from the stem of the problem. F and g are separated in terms of their numerical values. So let's go up here and rewrite what I'm being asked to find. We also have that constant multiple rule, so I know that I'm allowed to pull that out, right? So I'm pulling the 1/2 out front. I'm now going to do that separately from the other one. The other one I'll pull 3 out front. So then I'll just ask some of you guys to help me get started on this, because once you have this laid out, there's an easier piece, and so I want you to analyze that. Like, which one's easier for me to work with right now, the f of x integrand or the g of x integrand?
The g of x.
The g of x will be easier, so I like to come on. Let my brain rest if it can. Why is the g of x easier to work with?
It's just the opposite of the...
Yeah, I already have g right here. There's just one simple statement about it. The only problem is my information has the limits reversed, and I'm allowed to switch them, right? As long as I do what? Pull a negative out. Yeah, and the reason is when I switch the limits, then I'm no longer going in the same direction. So dx changes signs, which will cause the product to change signs. So really, for me to go from 0 to 3, I just change that to a positive 7. So I know I'll be subtracting 3 times a positive 7 from whatever the f of x integrand is going to yield. So then when I go look at the f of x, I go, ooh, they gave me 2 pieces of information. Only because they're chopping the whole way into what? Trying to analyze limits. What are they chopping 0 to 6 into? 2 pieces. And what's the boundary between the 2 pieces? Just based on the numbers. This is called numerical analysis. 3 is the splitter. So I want to figure out how much there was from 0 to 3. They told me the whole way is 9. This is common sense, right? They told me the whole way is 9, and the right side from 3 to 6 is 5. We're nodding now, which is awesome. So what must from 0 to 3 have been? 4. 0 to 3 plus 3 to 6 has to equal the whole way across. So this is really just a 4, but I had the 1/2 out front. So the correct answer that 12 of them got in the morning was 19. I'll tell you that most of the ones, I'm going to have you analyze this, most of the kids who had it wrong, I had some who just didn't know how to start, but most who did it wrong chose E. Analyze that. I said that's a small error, but it's really common, which is why College Board anticipated it and they felt like they had it right. What did they do?
They didn't switch the sign.
Yeah, they didn't notice that the limits weren't quite right, and they just stole the -7, and they ended up adding the 21. So that's what they did. That's such a anything common is anticipated, and it's there. If you don't find your answer, you made a very glaring mistake that's not common. Like you said 3 times 2 is 5. Like something that they don't anticipate. It actually makes it easier because it forces you to go back and check your work. If I got 23, I wouldn't go back and check my work. I'd be, what? So if you get it totally wrong, it means it's not something that most kids would do. All right. What do you think of that? It's not what we're doing today, but all right, easy peasy, mac and cheesy. All right. I want to go to next then. Not that. We did that yesterday. Yesterday. Boy, we were reproductive yesterday. Yesterday. Not today. Here we go.
Perfect.
Okay. Perfect. So go all the way to this page, and the first stuff I write down, I don't want you to write down. The reason is Number 73 on the last bookwork assignment that I collected was kind of a disaster. Many people just copied it out of CalcChat, and it was glaringly obvious because I haven't taught you that method yet. It's the worst method to use. A lot of people left it blank with a question mark, and there's one like it in your problem set and on your next test. So I want to make sure so don't write anything down. I'm going to just show you in this space. Number 73 said you were to integrate from a to b x dx, and you were supposed to prove that it was b squared minus a squared over 2. Do you guys remember this one? Those of you who CalcChatted it, the minute you hit enter or go or whatever you have to hit that popped up, you're like, what the heck? Anyone do that? Had like limits in it? Yeah, it was really weird. They were using what's called the formal definition of the integral, which we do at the very, very end, because nobody remembers it if I do it right now, because it's so weird. So, if you did that, you were just copying. A couple people in each class, though, figured out how to do this a different way. It's actually a better way. Did anyone do this one? What did you do?
Just try it out.
He did it with geometry. The reason he could is because the integrand y equals x is a what? A rigid line, which means we're going to have trapezoids or triangles underneath it. Y equals x, don't do this, goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Why is she saying it? You'll see why. All right? I'm supposed to go from A to B, drop it, integrate. Oh, I was going to try. I thought my fingertip was my shading tool. But I need to find the area of that. Agreed? What is that? It's a trapezoid, so you must have, Mr. Gill said, oh, I got a trapezoid. Do you know the formula for the area of a trapezoid? What is it? Go ahead, Gil.
1/2 the height.
Mm-hmm.
And the sum of the base.
Yes. Base 1 plus base 2. Can somebody supply the height for me? I cringed because all morning, for the last couple of days, I've been hearing the wrong thing for this. What is the height? Oh, thank you, Phil. Thank you. Guess what I hear all the time? A plus B, B plus A minus B. And I say, don't stab at it with, just if it was 2 to 10, you wouldn't say it's 12, you'd say 8, you do top minus bottom, right? So B minus A is what the height is. Now, when I was making these, I want to figure out base 1, okay, and I said it goes through 0, 0, 1, 1, a half, a fourth, A, comma, what? A, and 3, 3, and 4, 4, and 4.597, comma 4.597, because the y's equal the x's, and 7, 7, and 8, 8, and 9.1, 9.1, and b, comma. Boom. Right? So how high is the first base? Or how long is first base? A. Second base? B. Addition's commutative, so I'm going to go, I want to call b plus a for this proof. Because what will I do with these two binomials? Boil the bad boys or multiply them out, and on the top I get b squared minus a squared, correct? And on the bottom, what would I have? A 2. Thank you, guys. And that's how I would have done it, right? But the book did it a whole nother way. Now that I'm past this, and we did yesterday's, if I assigned this today, here would be the quickest way to do it over here in red. Use the fundamental theorem of calculus. What's the antiderivative of x? X squared over 2 from A to B. Oh, B goes in first, then A, and then I do what with them? That's the same answer. That's the same trapezoid, right? So, which do you think I, as a teacher, like better? Mr. Gill, who on a test does it in blue, or somebody who does it in red? Depends on the question. If it says use geometry to find that, then I will dock if you do not do the blue. On your test, I do have one where it says use geometry. I know you could do a shortcut to the left. It means I don't care about the answer. I want you to see a trapezoid. All right. Personally, if it didn't say, I like the thought process behind the blue because you can actually see what you're doing, right? But I like the speed and gracefulness of the red. I mean, that was just so fluid, right? I thought good. The blue was kind of B minus A. Anyway, I like them both, but guess which method I hate? The CalcChat copy one. because you haven't even learned it yet. So, and I don't know if I could even remember in detail how to do. I haven't taught it for a full year. It's a very complicated process. It's one thing that I do the very last day we do new material. Is I'm going to go through this, and about 30 you'll get it. The other ones you're just going to have to forfeit one multiple choice question, because there's only one ever, if that, on that formal definition. So it's really not a big deal. All right, what are we doing today, guys? You're supposed to tell us, Rude.
You're supposed to tell us.
Thank you, Carter. You're so obedient. We're gonna do something new, and I'm gonna have you go up here to the whoever's watching these notes. Who asked me to record this? Hogan. You're not gonna see that I'm crossing off the mean value theorem for integrals. I really don't want you to think of it with that name, because do I already have a mean value theorem? It's far more important and far more widely used than this one. So when you see MVT or mean value theorem, I do not want you to think of this. I want you to think of the one we've already done. Perfect time to review it, Sparky. Guess why? So, and I'd like to start reviewing. So let's talk about the mean value theorem for derivatives, the one you should always know. The hypothesis says if a function is
Continuous.
awesome and differentiable on a closed interval from A to B, there is at least one
Value such that.
C value, C such that, where is C? Between A and B, C is an X value, such that, what's the conclusion? Think of the picture.
C equals.
Don't think of the formula, just think of what I said that the things have to be, and then I'll walk you to the formula. You already have the whole prequel to this now, right? But what's my conclusion? There's some C such that the slope of the tangent line is parallel to the slope of the what? Secant. Now if you can think those words, you can give me a formula. How do we get slope of a secant line? That's from 7th grade algebra 1. F of y2 minus y1, which for us is f of b minus f of a over b minus a. Correct? Also called the average rate of change, is equal to the slope of the tangent line, which we know is the derivative, so we set it equal to f prime. There's one value that makes those equal or more, and you're going to find them for the mean value theorem. And that's what I always want you to think for mean value theorem. I want in your head to pop every time. MC equals M tan. Don't think of this. I'm going to have you more focus on the second average. Oh, there, I moved it. There you go, Riley. The other Riley, not that Riley. All right. So first of all, we're going to start again with my favorite graph. I draw this graph so many times. All right. We're going to go from A to B. We're going to have an f of A over here. Woohoo! F of B over here. Woohoo! A f of A. Bam. B f of B. Bam. And I'm just going to make a function that's easy for me to describe, or so I'm going to make a nice function so that's easy for me to do what I need to do. All right, this is also sort of an existence theorem, but it's not one you need to memorize. What this says is that if I go take this area under the curve, so you guys go do it, shade it lightly while I go grab my shading tool. I'm going to do it. Yep, yellow's good. Oh, I'm not feeling yellow, man. I'm feeling purple. Orange. Yeah, who likes orange? What color is your prom dress? Orange. Ew. Right? Gross. But make sure when you buy it, Carter, even if it's orange, if your dress is strapless, make sure you're bra.
Oh,
All right.
thank God. Thank God I believe you can do that kind of
Well, all right. Oh, Lord help us out. All right, let's back up here. So here's what I'm gonna strategically place C so that you don't know what I'm trying to make happen, but when I'm done, I'm gonna say, what did I make happen? All right, so I'm gonna put C. It's still in here somewhere. I'm gonna put it right about, I think there. Not quite in the middle, a little bit more to the right. When I was trying to decide where to put it, what I was doing in my head is drawing a rectangle that had this, that has this height right here. I was actually thinking I'm going to do this rectangle. You see it? I'm going to shade it in. This rectangle has this. It's orange almost. It's not orange. No, it's not. All right. The rectangle's area is the yellow and the red combined. Do you agree with me? What do you notice about where I put it? What do you think I was trying to balance out? Do you see that area in the purple that I missed? What was I trying to do, you think? Make sure I made up for it, right, in my rectangle. I was trying to make sure that the area of the rectangle was as close as I could kind of make it without being too, like, OCD, so that the area of the rectangle was equal to the what? Area under the curve. And what the mean value theorem for integrals says, which I don't know its title, but what it says is there has to be at least one value c so that such a rectangle exists. I don't care about that. I don't even care really if you can find c. What I care about is what I write in this next part. All right? So what it really states is that the area of the rectangle, I'm just going to write rect, is equal to the exact area under the curve. Technically, it's under the curve and above the x-axis, but you can see from my picture that that's kind of been inferred anyway. So there we go. That's kind of what it says in words. So let's talk about the icky notation for all of it. What do you think f of c really is on the rectangle? On the curve, it kind of looks, actually, that's funny. Who said that? You're hitting on something from logistics growth. That's actually a logistics curve. That is an inflection point. It's super important. But I meant for the rectangle, when I have this point c, f of c, when I think of it in terms of the rectangle, what is f of c? It's its height. Yeah. So where f of c is the height of the rectangle. That was weird, Hannah, because anyone in BC would go, oh, where did you pull that from? Because that's a super, I almost want to tell you. Okay. Do it. When you have logistics growth, things go crazy for a while. Kind of, they look like exponential growth. But then there's some limiting factor in the environment. Usually it's space or food supply. You know what I mean? Something that causes that growth rate to actually decrease. So it's kind of like a rumor. If I said, hey guys, did you know this kid? He's pregnant. And what would you guys do? I'd start that rumor, right? And you would start with it. Suppose it's prior to the texting where you could get that message outside of the school. You would immediately go to your next class and say, guess what? Nico's pregnant. Can you believe it? And everyone would go, what? And what would those people do? They tell people, and it would spread like gangbusters till it hits this point. I'm actually teaching you some health too right now. But you said it, so it's actually a very cool concept that's not at all about what we're doing. But it's fifth hour, and it's what we do, right? So right at that point, what you said is an inflection point, is where you turn to somebody and say, hey, guess what? Nico's pregnant. What do they say? I already know that. And it becomes harder and harder for you to shock somebody, which means that rate of growth slows down until eventually the growth rate approaches what? 0. But this inflection point right here, I just happened to, by accident, put up a fake logistics curve. That was not intended. But that point right there, which you said is an inflection point, is what my two kids have to find when it says, when is the bacteria spreading the fastest? When is the lice populating the fastest? When is the radioactive material expanding the fastest? Do you know what I mean? Because it's the fastest rate of growth occurs right there. It's kind of cool. Why did you say that? I wasn't even talking about the curve. I was talking about the rectangle. You made me look, and I'm like, oh my god, I drew a logistics curve. Anyway, I am sorry, Riley Hogan. All right, here we go. Anyway, and what is the base of the rectangle? Go up there. What's the base of your rectangle? I'm cringing. Thank you, because I'd blow a gasket if you said what again? A plus B, A minus B, throw them together somehow. No, you do top minus bottom. All right, so now let's go use some proper notation with this. Here's what I said. The area of the rectangle. Area of a rectangle is its base, which we just said is B minus